Hey everyone, welcome back to the channel. We are Engineering, Amco Industries, bringing you innovation in industrial solutions. Today, we're diving deep into a topic that affects millions of people every single day, yet often goes unnoticed: the air we breathe inside our industrial spaces. For decades, the image of a factory has been tied to smoke, dust, and questionable air quality. It's been a persistent challenge, impacting worker health, environmental standards, and even a company's bottom line. But what if I told you that reality is about to be completely transformed? Imagine walking into a massive manufacturing plant, a bustling warehouse, or a complex chemical processing facility, and the air is as clean and fresh as a pristine mountain breeze. It sounds like science fiction, right? Well, it's not. Groundbreaking advancements in industrial ventilation are on the horizon, and they're not just small improvements. They are a total revolution. We're talking about a paradigm shift that promises to create healthier, safer, and incredibly more productive environments for everyone. So stick with me, because today we're going to uncover how these innovations are making the impossible possible. Let's start by understanding the old way of doing things. Traditional industrial ventilation has largely relied on a principle called dilution ventilation. The basic idea is to bring in large volumes of outside air to mix with and dilute the concentration of contaminants inside, and then exhaust this mixed air back outdoors. Think of it like opening a window in a smoky room. It helps, but it's far from a perfect solution. This method is incredibly energy intensive, especially in climates where you need to heat or cool that incoming air. It's like trying to heat your house in the winter with all the windows wide open. It's wasteful and expensive. Moreover, dilution ventilation often just moves the problem around. It might lower contaminant levels inside, but it can release pollutants into the surrounding environment. And for workers stationed near the source of a pollutant, the diluted air might still contain harmful substances at dangerous concentrations. This has led to long-term health issues for countless workers and a constant battle for industries to meet ever stricter environmental regulations. The old systems were a brute force approach, a necessary evil, but they were never a true solution. So what's changing? The revolution is happening on multiple fronts, but it's all driven by one key concept: intelligence. The future of industrial ventilation isn't just about moving more air. It's about moving the *right air to the *right place at the *right time. Let's break down the core technologies driving this change. First up, we have smart sensors and the Internet of Things, or IoT. Instead of guessing where pollutants are, new systems are deploying networks of advanced sensors throughout a facility. These aren't just simple temperature gauges. We're talking about sophisticated devices that can detect specific chemical vapors, particulate matter of different sizes, carbon dioxide levels, and humidity, all in real time. Each sensor acts like a digital nose, constantly sniffing the air and feeding a continuous stream of data to a central control system. This data is the lifeblood of the new smart ventilation paradigm. The system knows instantly when and where a contaminant is released. Imagine a welding station that starts operating. Sensors immediately detect the fumes. A soldering process begins, and the system identifies the specific volatile organic compounds being released. This isn't a one-size-fits-all approach. It's precision-guided air quality control. This leads us to the second major innovation: demand-controlled ventilation and localized extraction. Once the smart sensors identify a problem, the system doesn't just crank up the entire building's ventilation. Instead, it activates targeted responses. Using variable speed fans and automated dampers, it directs powerful, localized extraction exactly where it's needed. Think of it like a surgical strike against pollution. A robotic arm with a suction hood can be positioned directly over the source of the fumes, capturing them before they even have a chance to spread into the general workspace. This is a game changer for both health and energy efficiency. By only ventilating intensively in the areas that need it, and only when they need it, energy consumption can be slashed by up to 60 or even 70%. The cost savings are enormous, turning what was once a huge operational expense into a much more manageable one. More importantly, it creates a drastically safer environment for workers, as their direct exposure to harmful substances is virtually eliminated at the source. But what happens to the air that's captured? This brings us to our third breakthrough: advanced air filtration and recirculation. The old model was to exhaust contaminated air outside. The new model is to clean it and reuse it. modern filtration technologies have become incredibly effective. We're moving beyond simple filters to multi-stage systems. These can include high-efficiency particulate air or HEPA filters that capture 99.97% of airborne particles, activated carbon filters that absorb chemical fumes and odors, and even UVC light systems that can neutralize viruses and bacteria in the airstream. By cleaning the air so thoroughly, it can be safely recirculated back into the facility. This is where the massive energy savings really kick in. If you've already spent money to heat or cool that air to a comfortable 70 degrees, why would you just throw it outside and pay to heat or cool a whole new batch of air? Recirculating preconditioned, clean air is monumentally more efficient. It also means the facility has a much smaller environmental footprint, as it's no longer venting pollutants into the atmosphere. It's a win for the company, a win for the workers, and a win for the planet. And the intelligence doesn't stop there. The fourth key element is the integration of AI and machine learning. The data from all those sensors isn't just used for immediate reactions. It's collected and analyzed over time. AI algorithms can learn the unique operational patterns of a facility. It can predict when and where pollution events are likely to occur based on production schedules, the time of day, or even which machines are running. This predictive capability allows the ventilation system to be proactive, not just reactive. For example, if the AI knows that a certain manufacturing process, which starts at 9 a.m., every day produces a spike in particulates, it can begin to ramp up a localized extraction system at 8:58 a.m., ready to capture the contaminants the moment they appear. It can also identify anomalies, a sudden spike in a chemical that shouldn't be there, and alert maintenance crews to a potential leak or equipment malfunction long before a human might notice it. This predictive maintenance can prevent costly downtime and dangerous accidents. So, what does this future look like in practice? Let's paint a picture. A worker enters a factory floor. Their wearable safety device communicates with the building's management system, which knows their location. As they move to their workstation, the localized ventilation adjusts, ensuring their personal breathing zone is supplied with a steady stream of purified air. A process begins, and a robotic extractor arm silently moves into place, capturing fumes at the source. The central dashboard shows a real-time 3D map of the facility's air quality, with every zone glowing green. Productivity is up because workers feel better, have more energy, and take fewer sick days. Employee retention is higher because the company is demonstrably invested in their well-being. The benefits extend far beyond just cleaner air. We're talking about a ripple effect that touches every part of the business. Lower energy bills free up capital for innovation. A safer workplace reduces insurance premiums and the risk of litigation. Enhanced productivity and reduced downtime lead to higher output and profitability. And being a leader in environmental stewardship and employee wellness becomes a powerful branding tool, attracting top talent and eco-conscious customers. This isn't a distant dream for the year 2050. These technologies are being deployed right now. Forward-thinking companies are already retrofitting their facilities and seeing incredible results. The silent revolution is already underway, turning our old, grimy notions of industrial environments on their head and creating the smart, clean, and efficient factories of the future. The question is no longer if this transformation will happen, but how quickly the rest of the industry will adapt. Thanks so much for watching. It's truly an exciting time for industrial technology, with a direct and positive impact on human health. What are your thoughts on these advancements? Let me know down in the comments. And if you found this video insightful, don't forget to hit that like button and subscribe for more deep dives into the technologies shaping our world. See you in the next one.